Hello, we're looking at problem number 2 from section 4-3, representing patterns in nonlinear functions. So here, this is an example of a nonlinear function. It says the table shows the total number of blocks in each figure below as a function of the number of blocks on one edge. So we have the number of blocks on edge. So we have 1. So here's 1 block here. And how many blocks total is that? That's 1. And then if I have 2 blocks on one edge, how many total blocks do I have? If I count all of those up, I should get 8. If I have 3, 1, 2, 3 blocks on one edge, how many total blocks is that? 27. And we want to know what do you think the next few terms are? So let's take a look at what they have. It says if we draw it, we'll see that we have 4 times 4 times 4. And if we draw the next one out here, we'll see we have 5 times 5 times 5. Well, when we look at it like this, it makes it kind of easy for us, right? We see that we have our number cubed. So that would be x cubed. So this is 1 cube, 2 cube, 3 cube, 4 cube, and 5 cube. So the equation will be y equals x cubed. And as you see when we draw it out, this will be nonlinear. So let's take a look at the guidance now. It says the table shows the number of new branches on each figure of the pattern below. What is a pattern you can use to complete the table? Represent the relationship using words, an equation, and a graph. So it says the number of figures. So if I have 1 figure, how many branches do I have? I have 3. If I have 2, let's see, if they have 2, how many are there all together? 9. If there are 3, so it's 1, 2, 3. How many are there all together? 27. So what do you think is going to happen here? What do you notice is going on with these numbers? Look like they're all cubes, right? So let's look at it another way. So if I have 3, 9, and 27, and this is really just kind of looking at patterns and looking at numbers. I see another way of saying this would be 3, 1. This would be 3 squared, and this would be 3 to the third. And so the next one would probably be 3 to the fourth, right? And the one after that would probably be 3 to the fifth. So if that's the case, it looks like each time we're doing multiples are 3. So another way to write it out would be y equals 3 to the x, right? If I graph it, I'm going to use my free graphing calculator. I'm going to just say y equals 3 to the x. I can actually put it in a chart also. So the first one was 1, and we had 3, and we had 2, and we had 9, we had 3, we had 27, so 4 would probably be 81. Let's see, let's turn this off so we can see it here. So I'm going to have to zoom out. Okay, so I can turn that back on so we can see. Oops. It looks like it's touching everything in there so far, right? So I hope this helps.